it to be quiet?
No. All right, hi everyone. This is lesson chapter 3436. So sorry for the little delay here in the videos. But these videos will match the notes that you received. And this section mainly focuses on quadratic functions. So we are going to dive a little bit deeper into quadratic functions. Okay, and just a refresher, quadratic is to the x squared. Okay, so kind of like an algebra 2 topic, so that's kind of the idea. But we do dive a little bit deeper into it. Okay, so first off is definition. And let's give a little definition here of quadratic function. So a quadratic function is a function of the form, and I'll use Echo-X notation just so you get used to it. Remember, it's the same thing as y. Ax squared plus bx plus c. A cannot be 0, and a, b, and c are all real numbers. Okay, so as far as that is kind of the idea. This is actually called standard form. So just as you have different forms in Algebra 1, you have slope-intercept form, you have standard form, you have point-slope form. In Algebra 2 or in quadratic land, you do have standard form, and you do have another form that we're going to look at called vertex form. Okay, so a couple of things about these. There are parabolas, which is a U-shaped. Okay, they all have vertexes, and a vertex is truly just a max or a minimum. So you will be able to find that on both cases. They all have domains and branches, so we'll be able to find that on both of them, or on all of them. And lastly, you can actually talk about increasing and decreasing. The graph does increase at a certain point, and it also does decrease at a certain point. So, but vice versa. So that's kind of the idea. As far as equations, what are they going to look like, or what are the functions actually going to look like? So a couple examples here would be x squared plus 2x minus 5, y equals 3x squared plus x minus 6. And both of those would be in standard form.
If there's trailing here,
and the reason is you can find an A, a B, and a C. So this would just be the A, B is just going to be 1, C is going to be negative 6. This should look very familiar when we did the quadratic formula. Hence it's called the quadratic formula because you use it for something that looks like that in standard form. Now the other form is going to be vertex. We're going to spend some time with this one here a little bit. Okay, so that one looks something to that effect. Something like that. And this is called vertex form. And we will spend a little bit of time with it, but the A is still out front. This time, instead of a B and a C, you have something called H and a K. Okay, so that becomes increasingly important. This form should look familiar when we shifted the graphs left and right, up and down. This should look familiar there. So as far as A, that would be your A. Your H ends up being backwards, so the H is actually negative 3 here. And then the K is the negative 1. So it's important to be able to pick out all of those letters, but it's important to be able to pick out all of those letters. Okay, so let's dive a little bit deeper into the graphs. So the first task we are going to look at is standard form. Actually, no, let's do vertex form first. I think it's a little easier. Okay, so let's start with vertex form. Okay, so recall, vertex form inside is A parentheses x minus the h squared plus k. Alright, so first off the A. If the A is positive, it means your parabola is going to go up, or it's going to keep happy. If A is negative, it means your parabola is going to go down, or it will be flipped down. So we just saw that last week when we did the flips of the graphs. Now, the beauty of this form is the H and the K. The H and the K is literally the vertex. There is no math to perform here. The H number becomes the X value, and the K number becomes the Y value. So that is just your vertex. That should also match your phase shift that we saw last class. Okay, and we'll go ahead and talk about that. But as far as that, that's kind of the beauty of that form. Okay, so I have two here. We're going to start with one first. And I wanted to look at this one first. Okay, so as far as this first example, A is 1. So when I pick out that A, that does become 1. H is opposite, that is 2. And K does match, that's -3. Now, how does this match the phase shift? If you recall from last week, the inside shifts backwards. So -2 would look like it would go to the left 2, but it actually does not. That goes to the right 2, and this can cause it to go down 3. So right 2 is +2. So that's where the 2 comes from for the H. Down 3, that would be -3. Okay, so that's where that comes from. All right, so with that said, you automatically know then your vertex is 2, -3. I also know that since A is positive, my graph is going to go up like this. That's a great start. That's basically where you should start every single time you graph a parabola. So when you look at the graph here, over 2, down 3, that's the vertex. You know that is the very bottom point because my parabola is going up. Okay, so the next points, and we're just going to do a sketch here, but the next points are going to be over 1, up 1, and that would be your parabola. So I just need you to sketch the vertex. You need to be able to find the H, the K, and things like that. Okay, now, as far as this parabola, there's a bunch of questions you could actually answer for this thing. So we already have the vertex. Okay, so I'm going to kind of underline that because we already have that. Related to that is called the axis of symmetry. These parabolas have a symmetrical feel to them, and they have an imaginary vertical line that you could fold that parabola right across. Okay, so that axis of symmetry is a vertical line, and it's always at an x value. So the axis of symmetry here is x equals 2. Okay, so that's another key point about those parabolas. The other thing is the increasing and decreasing. Let's start with decreasing. Okay, so decreasing. Remember, you read the graph from left to right. So if I start here and I read, my graph is technically decreasing. Okay, and it's decreasing the whole way down to that point. Well, that point is 2, -3. So if you remember from last week, decreasing, where it starts -infinity, and where does it go to? And you have to use x values. So technically, the decreasing interval will be from -infinity to 2. Remember to use x values. Likewise, for the increasing, I'll put a note here, use x values. For the increasing, increasing will start here at 2, and again, it would go up. So that would be increasing. So increasing would be from 2 to infinity. Okay, and it's literally the other piece. Okay, so one piece decreases, one piece increases. Okay, domain. We saw last week domain. Domain of parabolas is super easy. Every x value will work into that equation. There is no restrictions, guys. Do not forget this. The domain of parabolas is all real numbers. Okay, always. No matter if the parabola goes up or if the parabola goes down, the domain is all real numbers. as far as the range, when you look at the range, you have to remember to look at the y values. So the range would go from the bottom to the top. So how low does this parabola go? Remember, now we need to use y values. So that parabola starts at -3, and it goes the whole way to infinity. So the range would be -3 to infinity on that. And that is the 6 things that you will have to be able to find from these graphs. Okay? All right, so with that said, I kind of want to do one more just to give you another example of one. So let's go ahead and do the second example here for vertex form. Okay, so y equals negative x plus 1 squared plus. Okay, so again, it's in vertex form. How do I know that? There's parentheses. A is -1. H is -1 also. And K is 4. And remember, the shift here was left 1 and up 4. So that would be, that's why that H is negative. So it does follow the actual phase shift to that. Okay, so putting everything down on paper, again, just to kind of highlight things here, you will have to be able to find the vertex. So remember, the vertex is literally just the H and the K. Okay? You will have to be able to find the axis of symmetry. And at this point, it might be helpful to draw a graph. Okay, so my vertex is -1, 4. And keep in mind, because the A is negative, that parabola is going to be upside down. So the parabola is going to be that way like that. Okay, so that would be your sketch of that parabola. So the axis of symmetry is in fact right there at -1. Guys, yes, it will always be the x value of the vertex because it goes right through the parabola. Okay? All right, so moving right along, keep on going. We have decreasing. Okay, so where does this parabola decrease? Increase or decrease, doesn't matter which way we do. We'll go ahead and do increasing first. So increasing the whole way up to there. Now remember, you got these x values. Okay, so x is -1 there. So the increasing is going from -infinity to -1. Decreasing interval is going from -1 then to infinity. Okay, so remember, this is -infinity over here, +infinity over there. So if you're going towards that direction, that would be the infinities. Now, as far as domain, remember I told you don't forget this. The domain for parabolas is always all real numbers. You could draw the R, or you could also write -infinity to infinity. It doesn't matter. And lastly, the range. So how low does this parabola go? Well, wait a minute. It goes down forever. So -infinity. How high does this parabola go? Remember, you're looking for a y value, and that's going to be 4. Okay, so your range is a different look. You have to remember to go from the bottom to the top for that. Okay, so as far as those numbers, know where all of those numbers come from. Okay, it's key, and all the numbers are kind of connected within each other. So once you find this vertex, everything else is pretty much interconnected. So that's vertex form. So next, let's go ahead and look at standard form. Okay, make sure we can do standard form. So standard form. A little bit harder. So standard form looks just typical like the quadratic formula kind of stuff that we've dealt with. So you'll see an x squared, you'll see an x, and then you'll see a number at the end with nothing. Okay, so as far as standard form, okay, so let's go ahead and go through a couple standard forms here. We're going to go ahead and do example 1. Y equals x squared minus 8x. Okay. so as far as standard form, do we have an H and a K that we can jump straight to vertex? And if you take a look at this, you should be saying, no, we don't. Okay, that is the problem. There is no vertex, so we have to find it. Okay, so far you have an A, which is 2, you have a B, which is -8, and you have a C, which is 4. But that is all you have. Now, you are going to need a little formula to find the vertex here. And I do want you to recall, if you remember the quadratic formula, the front of it says opposite B, the bottom says over 2A. Opposite B over 2A will actually give you the X value of the vertex. Okay, so, and that's just the front part of the quadratic formula, by the way. So if I do that first, I will end up with the X coordinate. So X equals opposite B, since it's -8, it's going to be 8, all over 2 times 2. So 8 divided by 4, which is 2. So you just found the X coordinate is 2. Now how do I go back and find the Y coordinate? You have to go back to the equation and substitute. So the equation is 2x squared minus 8x plus 4. We have to actually plug a 2 in there. 2 times 2 squared minus 8 times 2 plus 4. That's y equals 2 times 4 minus 16 plus 4. And if I keep on going, it's 8 minus 16 plus 4. And that's -8 plus 4. So y is -4. And your vertex is -4. A lot harder to find the vertex when it's not in vertex form. And unfortunately, this is the only way to do it. Okay? So, with that said, now I can finally go to a graph over here. And I can go to 2, and I can go to -4. And keep in mind that A was positive. A is positive 2. So that means the graph will go up like this. So just give me a sketch there. So that would be the sketch of that parabola. Okay, as far as the same questions, you should be able to answer the same questions now. Axis of symmetry is x equals 2. Increasing, I'm going to do increasing. Increasing is 2 to, looks like infinity. Decreasing is negative infinity to 2. Not -2, infinity to 2. Okay. Domain, total numbers, get that. And range is going to be, and range is going to be from the lowest point to the highest point. So -4 to infinity is going to be your range. It should be right, not actually touch -4. Okay, so, but as far as that, that is all the parentheses, or that is all that you can answer from that graph. Okay? So notice the vertex process is a little longer, and you will have to know how to do that process. Okay? So, one more, just to make sure you can do that process. And we are going to do y equals -x squared plus 4x minus 4. Okay, so taking a look at this, I know it's in standard form, so I know that's standard. So A is -1, B is 4, and C is -4. Since it's in standard, I have a little bit of process to find this vertex here. So I do have to use opposite B over 2A. And that will give me the x. So plugging everything in, opposite B is -4. 2 times -1. -4 divided by -2, and that's 2. So far, I have found that the x coordinate for the vertex is 2. Now, when you want the y coordinate, you do have to go back in, and you have to plug it in. So -2 squared plus 4 times 2 minus 4. That ends up being -4 plus 8 minus 4. And, have a neat answer here, 0. Okay, so your y coordinate for this vertex is 0. At that point, I would probably stop and draw a graph. 2, 0 means it's right on the x-axis here. A is negative, so since A is negative, that means we're going to have a sad parabola. or upside down. Okay, so it's going that way. All right, so as far as the questions, axis of symmetry. The axis of symmetry is literally just the x-coordinate, so it's x equals 2. C, decreasing and increasing. It doesn't matter if we do first. Decreasing is from this point to positive infinity. Remember, it's positive infinity. Decreasing uses the x. So that point is actually 2, 2 to infinity. Increasing, a little bit more difficult. That's negative infinity to 2. So that's on the other side. So we'll do this over here. Okay. Domain, I never miss domain. Domain is all real numbers. That will never ever change for any quadratic function. And F is the range. So how low does this graph go to how high does this graph go? This graph goes so low, goes to negative infinity. How high does it go? Be careful, it's not 2. Remember, you're using the y here now. So how high does this graph go? It does just go up into 0. Okay? So, again, 2 different forms, same information. The only thing that's really different is the vertex. So in the vertex form, you can find the vertex easily. If it's not vertex form, you are going to have to do the negative b over 2a to get the vertex. And be careful when you do that problem, because if you miss that vertex, you tend to miss a lot more stuff in there. Okay, so with that said, I'm going to stop. That's going to be my first video for today. Probably going to do 3 short videos today, so that will be the first one. Okay guys, see you in the next one.